This video is going to go over the good stuff, the results of your quantitative methodology chapter, right? The results, that means you're almost through. So let's get looking at the results. First thing is, some committee members might want this in a different chapter, okay? So some want results in your last chapter, some want it with your methodology chapter. So we're just going to put it in a methodology chapter. But again, talk to your board members and see where they want them. Okay, let's get going. First thing about your results, you want to talk about your data cleaning. You got to tell them how you cleaned your data. In other words, what were the reasons you got rid of some of your participants? How did you screen the people that were going to be used in the study? That kind of stuff. They're going to want to know, how many people did you toss out for not filling out at least half the survey? That's a big problem, especially in today's world. We have those darn bots. The bots will get into your Qualtrics or your SurveyMonkey, and they pretend to be a real person, and they're able to answer questions at random until they are able to get in. But usually there's a way to tell. You look at their values, and they'll all be 3s or all be 4s or something. They're all the same number. So basically, you want to dump those losers. So next, you want to talk about your integrity checks. In a survey, an integrity check has many different types. There are one very common one is, 7 plus 2 equals, that's the question. And then you have a bunch of different answers in the middle, and only one of them's correct. So if they miss that one, that tells you that that participant is just kind of not paying attention. You should probably delete that person's responses from the survey. Another one is, you're trying to measure, like, let's say, depression. You could have 3 or 4 or 5 different questions all measuring depression, but one of them could be reverse coded, right? So, 4 questions are, the higher the number, the more depressed they are. But on that 5th one, it's a backwards question. You're asking about how happy they are. If they're depressed, they should have 4 high on depression and then the 1 low on happy, right? So they're opposites of each other. But that's how you do an integrity check on the people that are taking your survey. All right, now we're getting into the juicy part, the demographics. Remember, the demographics are like a snapshot of who's taking your survey, right? Their gender, their age, how much money they make, how much education they've had. There's a pretty solid list you can look at. But you got to talk to your board members and tell them what exactly were your demographic variables. What kind of information were you collecting on your survey takers? Now, what were your nominal variables? That's normally gender or ethnicity, something that puts people in groups. And then what were your continuous variables? Now, that could be a person's age, length of a relationship, how much money they have in the bank. But now be careful with your continuous variables. If you put them into levels, that would make them an ordinal variable. So if you got ordinal variables like that, you should tell them what they are. So again, let's take that, your age variable. It could be a continuous variable, right? Just how old are you? But an ordinal variable, you would say, 25 to 35 is one level. 36 to 45 is a second level, right? You put them in groups by age, that's an ordinal variable. Identifying these variables are important. It tells us, the reader, that once we know what the variable type is, either nominal, continuous, ordinal, and what you're looking for in your hypothesis, are you looking for a significant difference between some values based on a person's grouping? Or are you looking for some kind of relationship between 2 variables, 2 or more variables? That tells us exactly which test that you're going to use. Again, some teachers might want this in an appendix or something, but some teachers want to see your demographics, what they look like in the results section. So you got 2 ways to illustrate what your participants were like. So the first one is frequency tables. Some teachers prefer these, right? It gives you the group. This is a categorical or a nominal variable. How many were male? How many were female? And there's another one for age groups. Now, quick quiz. What kind of variable is age groups? Ordinal is correct, right? So, right, because the order of the years increases as it goes down, right? So that's That is an ordinal variable. But again, some teachers prefer the frequency tables and other teachers prefer the bar graphs. Personally, I like the bar graphs because watch how quick it is on your brain to see which one is the bigger group. Bam! Right there. So it's obvious, right? That's why I like bar graphs. You don't have to think so much. But it's obvious, right? More males than females. This one is, most of them were under the 34-year age group, that kind of thing. So, but again, ask your board what they prefer. Some want one, some want both. Some want them in an appendix. They don't want them on the main body of your dissertation. Reliability of coding. This is actually very important. Now, sometimes Qualtrics, if you use Qualtrics, I've been using it for, 15 years now. And even though you have a survey question on Qualtrics that has maybe 7 different answers, right? Strongly disagree, that kind of thing, where it's 1, 2, 3, 4, 5, 6, 7, and 7 is strongly agree. Even though you think it's 1 through 7, when you download the data and you get it on SPSS or Excel, you don't get 1, 2, 3, 4, 5, 6, 7. Sometimes you get 18, 19, 20, 21. You get the weirdest numbers. Don't know why, still trying to figure that out, but it's probably something on our side. But the reliability of the coding. So if you got to code something, make sure that it's coded correctly to what you are trying to measure there. Always double check Qualtrics. And then sometimes you got to double code. What that means is the author of wherever you got the survey question tells you exactly what to do. Like if they picked your third option, you mark them with a -1. If they pick the first option, you mark them with a +1, something like that. That's called double coding. Gets kind of complicated, but it's doable. Make sure that you didn't miss any reverse coding, right? Reverse coding, that's that negative measure, like we talked about, 4 being depressed, 1 being about happiness, right? The happiness is a reverse measure of depression, right? So just make sure they should be marked right after wherever you got the questions. There's usually a little paragraph or two that says, reverse these questions. Boom. The last thing is how you check in the reliability of your surveys. Now, that should be either a Cronbach's Kappa or retest reliability. We tend to use the Cronbach's Alpha because SPSS does it so fine. But that's how you check the reliability of your survey. So now you got missing data and the distributions. I kind of mushed them together here in this one section for expediency. Missing data. It's common for people to miss 1 or 2 questions. It's not a big deal. Other people are missing too many answers. Okay, so you have to tell your audience, how did you handle the missing data? First of all, some of your survey takers might not have finished your survey very well. We use the rule of thumb of 50%. If they didn't finish at least 50% of the survey, we kind of kick them out. We have another rule of thumb that we use. If the data missing is less than 5% of the sample size, just leave them blank, right? The software knows what to do with a blank cell. And the good news is, it's very, very rare that 5% of any data set is going to affect the outcome. Keep that in mind. Now let's talk about the distributions of the data. We're only talking about the continuous variables, right? Are they normal? Only continuous variables are normal. You know what that means by now. Just remember, normality does not apply to the nominal variables. No such thing as normality when it comes to categorical variables. I get that all the time, so don't make that mistake. Now, for your multiple regression models, was there any kind of intercorrelation between your predictor variables? In other words, were 2 of your IVs more strongly correlated with each other than they were the DV, question mark? That will trigger your violation of your multicollinearity assumption and probably your autocorrelation assumption, which means you got to do something. So if you're looking at means from your sample, did you compare them to published U.S. norms? Remember, a norm is a population mean. So are they close to the stated U.S. means? Or are they not, right? That gives you something else to write about. All right, hang in there, team. Getting down to the nitty-gritty. So now we're going to talk about the evaluation of your hypotheses, right? This is the whole chimichanga. This is what everybody's been waiting for. Did you find significance or not? Let's take a quick look on how to report that. I thought I'd add in something important here. We have to address a very common reaction to students. Importante. Sí, es muy importante. It's very important that you guys got to know this. That sometimes your hypotheses will be supported. That means you're going to find significance, etc., etc. Or sometimes they will not be supported, which means they weren't significant. So in other words, whatever your hypothesis was looking for wasn't supported by the data. That doesn't mean it wasn't there. It just means the data is not supporting it. Now, either result is fine. Your teachers are trying to see that you can do research properly. Just think about it a little bit. Did you really expect all of your hypotheses to be proven correct? If you did, that's not a good attitude towards doing research, right? You don't know. That's why you're doing the research. You're like investigative reporters. You're fact-checking, right? Empirical proof. That's what you're looking for. So it's either there or not there. There is no right or wrong here. You're just showing if the data does support your hypothesis or not. Okay, enough about that. Let's continue. First thing, use past tense. Always use past tense when you're writing about the results because you already ran the tests, okay? Number 2 is make darn sure that it's in APA formatting. We're up to APA 7, I believe. There's plenty of online resources that you could check. But again, APA formatting for both the text, reporting the results, your tables and your graphs, everything has an APA format attached to it. State the results of each analysis clearly as possible, right? In other words, can your results be interpreted by somebody that's not into statistics? That's important, right? Ease of understanding. That isn't actually an art form, so make it easy to understand. Was there significance, right? That's the golden rule here, right? That's your holy grail. Was there significance? And again, if there was, you should report the effect size and the power. Normally, if there wasn't significant, a lot of people, we don't care about the effect size or the power because it wasn't significant, right? It's not important. But again, if there was significance, you're supposed to talk about the effect size and or the power. Normally, the power we only talk about is in the ANOVA family because that always needs such a big sample size. But you can run a post hoc power analysis using G-power on any test, okay? So if they want you to do a post hoc power analysis, we can do that. And remember, power is basically how sensitive your test is at not rejecting the null when it's not supposed to, which kind of means rejecting it when it's supposed to as well. So, but that's what you should do if it's significant. Now, just a quick sidebar. If you're running a factorial ANOVA, right, that means you have more than one categorical variable, but just one DV, right? So if there was an omnibus F, in other words, the first ANOVA on that first corrected model line in your SPSS shows that the F was significant. That means there's a significant difference in there somewhere, but it doesn't tell you which groups are significantly different. So if there is a omnibus F, you're supposed to report the main effects. All that means is, was there a significant difference in whatever the DV was between your first grouping variable? And then again, was there a significant difference in whatever the DV was between your second levels, the levels of your second variable, etc., etc. That's what main effects is. Now, if there was a significant interaction, then you're supposed to look at the simple effects. So simple effects goes into a lot of detail, but we have videos on that. So if you need to check on that, go ahead and go check out the Hawk online stats resources. Bum, 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 bum. And again, we're going to beat you to death about the assumptions. Every test has its own set of assumptions. The harder the test, the more the assumptions. But you got to check them. And SPSS does a fine job of checking them for you. And if something was violated, which is not uncommon, did you make any corrections to the data? In other words, did you Windsorize it, Shepardize it, transform it? Personally, I don't like any of these. Windsorizing is you're literally changing values. Shepardizing is the same thing. You're changing values. Transformation is you're destroying the linear relationship and turning it into a non-linear relationship. But that's my 2 cents worth. Okay, again, If something was violated, what did you do about it? And I think we're getting close to the end here. Dun-da-da. Oh, yeah. Post hoc analyses. Post hoc literally means after the fact. So after you ran your test, did you run any post hoc analyses? Now, around here, the only thing that we check for with using a post hoc test is for the ANOVA family. So let's pretend you're running an ANOVA between the 6 military branches, and the DV is how many hot dogs they can eat in 20 minutes, something like that. And there is a significant difference. It doesn't tell you, the ANOVA doesn't tell you where the difference is. It could be between the Marine Corps and the Space Force, or between the Coast Guard and the Navy. It doesn't tell you where it is until you run a post hoc analysis. So again, we use post hocs a lot in the ANOVA family. With that said, you need at least 3 groups to run a post hoc analysis for an ANOVA. And so this next slide should segue from the post hoc test. Remember, post hoc is after the test has been run, and it does. Trick or treat. That's it for this one. Okay, so I hope this helps.
Math Guy Zero, out.